Yes. Okay, so let us start with the MCQs from ray optics. ओके, तो जैसा कि हम लास्ट टाइम हमने थियोरी पूरा कवर कंप्लीट किया था, तो आज के लेक्चर में हम पेयर ऑफ स्ट्रेट लाइन के रे ऑप्टिक्स के एमसीक्यूज देखने वाले हैं. यस, आई होप यू कैन सी द स्क्रीन. तो यहाँ पे रिफ्रैक्शन ऑफ लाइट के अंदर हम ये एमसीक्यूज देखेंगे अभी फटाफट. लेट अस सी दिस फर्स्ट क्वेश्चन इन डिटेल. Okay, let us take it on our board. Yes, just read it carefully. Which of the following ray diagrams show physically possible refraction? Okay, so we want to find out the physically possible refraction from these ray diagrams. Okay, so see here. So first of all, we have to keep in mind that whenever a ray of light just travels from rarer medium to denser medium. Suppose this is the denser medium and this is rarer medium. So whenever the ray of light travels from denser medium to rarer medium, it always bends towards the normal. And on the other hand, if it travels from denser medium to rarer medium like this, okay, so अगर कोई भी ray of light अगर denser medium से rarer medium के अंदर अगर enter करता है, तो उस केस में वो क्या करता है, it always bends away from the normal, right, like this. Okay, so in that case, angle of incidence is always going to be greater than the angle of refraction is going to be greater than angle of incidence. And in the previous case, when the ray of light travels from rarer medium to denser medium, angle of incidence is going to be greater than the angle of refraction. Okay, तो ये चीज़ हमको अच्छी तरह से याद रखना है. इसी के ऊपर ये पूरा क्वेश्चन बेस्ड है. Okay, so let us consider it here. So in the first diagram, if we see carefully, then this n equal to 1.4, मतलब ये this is actually going to be the rarer medium actually, correct है? Because its refractive index is less, whereas this n equal to 1.6 means it's going to be a denser medium here. तो यहाँ पे वो denser medium की तरफ यहाँ पे जा रहा है. तो अब normal अगर हम draw करेंगे यहाँ पे, so normal can be drawn here like this. Okay, so this can be the normal here. So now if we just see carefully, then what can we observe is the angle of incidence here. Sorry. So the angle of incidence is actually going to be greater than the angle of refraction, correct है? And the ray of light is appearing to bend towards normal, and it is correct, it's true. It has to be because ये जो ray of light है, तो वो जो normal के साथ angle बनाता है, angle of incidence हम उसको बोल सकते हैं. और यहाँ पे ये जो है सेकेंड रे ऑफ लाइट जो है, रे ऑफ रिफ्रैक्टेड लाइट जो है, वो नॉर्मल के साथ जो एंगल बनाता है उसको हम एंगल ऑफ रिफ्रैक्शन बोलते हैं, ये वाला. तो अभी यहाँ पे हमको क्लियर पता चल रहा है कि आई इज गोइंग टू बी ग्रेटर दैन आर. एंड रिफ्रैक्टिव इंडेक्स जो है, तो वो यहाँ पे रेयर मीडियम का कम है और डेंसर मीडियम का ज़्यादा है. ठीक है, तो व्हेनेवर द रे ऑफ लाइट ट्रेवल्स फ्रॉम रेयर मीडियम टू डेंसर मीडियम, इट हैज़ टू बेंड टुवर्ड्स द नॉर्मल, and that is correct here in this case. Okay, but if we just see in the second diagram, then we can just note that the incident ray and refracted ray both lie in the same side, on the same side of the normal, which is against the second law of refraction, which we already know that it doesn't take place like this. तो मतलब अगर ray of light अगर ऐसे अगर इंटर करता है, तो it should bend in this way here, right? So if it is traveling from denser medium to rarer medium, then it should bend towards the normal, but it should be in opposite direction. Opposite side में वो होना चाहिए. तो normal के opposite side में वो होना चाहिए. जबकि यहाँ पे दोनों same side में दिख रहे हैं, जो कि एक contradiction है. इसलिए ये second वाला जो diagram है, it is again not physically possible. If we just talk about this third one here, तो यहाँ पे ये जो third वाला diagram दिख रहा है, तो उसके अंदर हम देख रहे हैं कि denser medium कौन सा है. सो ये जो n इक्वल टू 1.5 करके दिया हुआ है, ये वाला हमारा सॉरी रेयर मीडियम ही है, ठीक है, वी कैन कॉल इट एज अ रेयर मीडियम, ओके, एंड दिस इज एक्चुअली गोइंग टू बी द denser medium. Yes, but as we can just see that ray of light is bending away from the normal while traveling from rarer medium to denser medium, which is again a contradiction. So therefore this is again not a physically possible, this is again not a physically possible, only this first diagram is physically possible. So therefore we can just select this A as a correct option here. Okay, yes, let us go to the next question. Okay, here it is, the second question we can see. Let us take it on the board. Okay, following figure shows the multiple reflections of a ray of light along the glass corridor. ओके, तो यहाँ पे हमको मल्टीपल रिफ्लेक्शंस होते हुए दिख रहे हैं रे ऑफ लाइट के। तो ये जो रिफ्लेक्शन का डायग्राम है वो हम थोड़ा सा इनलार्ज करके अगर देखते हैं, ये देखो, सपोज दिस इज द डायग्राम ऑफ रिफ्लेक्शन। सो इफ यू जस्ट सी केयरफुली देन यू कैन जस्ट नोट, यहाँ पे हम अगर नॉर्मल्स अगर ड्रॉ करेंगे हर एक पॉइंट पे, जैसा कि पॉइंट पी पे अगर हम नॉर्मल ड्रॉ करते हैं यहाँ पे इस तरह से, ये बन गया पी के ऊपर का नॉर्मल सपोज। Yes, then we can just see the normal of the point Q here. इस पॉइंट Q पे भी हम नॉर्मल ड्रॉ कर सकते हैं आराम से ऐसे। यस, देन अगेन R के ऊपर भी हम नॉर्मल ड्रॉ कर सकते हैं इस तरह से। ओके, एंड S के ऊपर हम नॉर्मल ड्रॉ कर सकते हैं ये वाला। एंड फाइनली वी कैन जस्ट ड्रॉ द नॉर्मल ऑन T also. Okay, so here it is given already that the angle of incidence at point P is going to be 30 degree, right? तो अगर P पॉइंट का एंगल ऑफ इंसिडेंस 30 डिग्री है तो इसका मतलब ये वाला एंगल जो है वो 30 डिग्री हो गया। चलो ठीक है, अगर ये 30 है तो एंगल ऑफ रिफ्लेक्शन विल ऑल्सो बी 30 डिग्री बिकॉज ऑफ द लॉस ऑफ रिफ्लेक्शन, एंड बिकॉज ऑफ द alternate angles this will also be 30 degree, and at the same time according to the laws of reflection this angle will also be a 30 degree only, no doubt. But here if we just extend this line normal further so as to meet the normal at point R here, then it forms a right angle triangle here. Okay, we can just consider this as a right angle triangle, so that this angle 30 and the angle of incidence at point R here should be complementary angles, so that we can just note this as 60 degree here. If it is 60, then we can consider this also to be 60 just because of laws of reflection, and since this is 60 we can just call this also to be simply 60, and because of the alternate angles, and here this also will also be 60 here, and because of the complementary angles this finally will actually be 30 here. Okay, and obviously this will also be the 30 only. ओके, तो ये सब सारे एंगल्स हमको मिल गए यहाँ पे। तो इसको यूज़ करके हम अभी कंक्लूड कर सकते हैं। देखो हमको निकालना क्या है, व्हाट आर द एंगल्स ऑफ रिफ्लेक्शन ऑफ लाइट रे एट पॉइंट्स क्यू आर एस एंड टी रिस्पेक्टिवली। तो क्यू पे एंगल ऑफ रिफ्लेक्शन कितना है, 30 डिग्री है, ठीक है। आर पे रिफ्लेक्शन एंगल कितना है, 60 डिग्री है। फिर एस पे एंगल ऑफ रिफ्लेक्शन कितना है, 60 डिग्री है, और टी पे कितना है, 30 डिग्री है। So we can just say that the angles of reflections at QRST are simply 30, then 60, again 60, and 30 here. So that we can just consider this 30, 60, 60, 30. मतलब C will be actually the correct option here. Okay. So this C will be the correct option of this question. Let us see the next question. That is the third question here. Yes, just try to read it. When the rectangular metallic tank is filled to the top with an unknown liquid, as observer with the eyes level. Okay, so observer is there at the eyes level. With the top of the tank can just see the corner. तो मतलब ये observer जब यहाँ पे देखता है तो he can see the corner of this tank here. Okay, the ray that refracts towards the observer at the top surface of liquid is shown. Okay, मतलब ये जो रे है वो यहाँ से स्टार्ट होने वाला जो रे है वो इस टॉप सरफेस पे रिफ्रैक्ट होके ऐसे यहाँ पे इंटर करता है, ये दिया जा रहा है, दिखाया जा रहा है. द रिफ्रैक्टिव इंडेक्स ऑफ लिक्विड विल बी. ओके, तो रिफ्रैक्टिव इंडेक्स निकालने के लिए देखो हमारे पास एक फॉर्मूला है, क्रिटिकल एंगल का फॉर्मूला है, याद होगा तुमको, म्यू इज इक्वल टू 1/sin IC. ओके, where IC stands for critical angle here. And if we just see the diagram carefully, then the angle of incidence in the denser medium for which the refracted ray just passes grazing the surface is itself called as the critical angle. So this angle actually should be called as the critical angle. We can just call it as IC. And if we just try to find out this IC, sin IC from the diagram, then we can just work it out, because we have this opposite side given here to be 4 centimeter and adjacent side is already given to be 3 centimeter, right? So that we can be able to calculate the hypotenuse to be 5 centimeter by using the Pythagoras theorem. And once we get it, we can just try to find out the sine of IC from this triangle itself, right angle triangle here. So sine IC will actually become equal to 4/5. So that we can just put this value of IC here in the denominator, so that we can get this mu to be simply equal to 1/4/5. Correct hai? And 1/4/5 actually comes out to be 5/4. Okay, so this becomes 5/4 here, which can also be written to be approximately 1.25, which is there already in option A here. Okay, so in this way we can find out the refractive index, no doubt. Let us go to the next question, that is fourth question here. Yes, let us take it on the board. Just read it carefully. A ray of light strikes a plane mirror at an angle of 45 degree as shown in the figure. After reflection, the ray passes through the prism of refractive index 1.5, whose apex angle is 4 degree. The total angle through which the ray is deviated is. Okay, so first of all, just see that if in the absence of this mirror, the ray would have gone in this direction. Okay, तो ये ray जो है वो इस direction में जाता था. So this direction will actually be the original direction. So, but it travels in this downward direction actually, so that there is a angle of deviation of 90 degree already there due to this plane mirror. Okay, इस plane mirror की वजह से उसके अंदर 90 डिग्री का deviation तो already हो चुका है. अभी फिर से अगर हम बात करते हैं यहाँ पे कि ये प्रिज्म के एब्सेंस में ये जो रे ऑफ लाइट है वो इस डायरेक्शन में जाना चाहिए था, लेकिन अभी प्रिज्म की वजह से क्या हो रहा है, इट इज पासिंग इन दिस डायरेक्शन हियर, बट बिकॉज ऑफ दैट प्रिज्म ऑल्सो प्रोड्यूसेस सम डेविएशन हियर. तो प्रिज्म के द्वारा जो प्रोड्यूस किया हुआ डेविएशन है, तो दिस इज द ओरिजिनल डायरेक्शन एंड दिस कैन बी कंसिडर्ड एज अ final direction. So the deviation that is produced by the prism alone is going to be denoted by delta here. उसको हम delta से denote कर सकते हैं, and this delta can be found out to be found out by using the formula already we have. But after all, the total deviation here is actually going to be 90 plus this delta here. Okay, the total deviation जो है वो यहाँ पे 90 प्लस डेल्टा के बराबर रहने वाला है. So we can just have this total deviation to be 90 plus delta, where delta can be found out by using the formula that is a into mu minus 1, which is already we have derived it in theory. Okay, so if we just use it here, then we can be able to get this a, where a is nothing but the angle of the prism, refracting angle of the prism, which is already given to be 4 degree here. That is multiplied with refractive index, which is already given to be 1.5 here. Okay, so 1.5 as it is, and minus 1 kept as it is, so that this 1.5 minus 1 actually becomes 0.5, and 0.5 multiplied by 4 actually comes out to be 2 degree. And if we just put it here, then we can just be able to get the total deviation to be 90 plus 2, which is actually going to be 92 degree here, which is already there in the option C here. Okay, which can be supposed to be the correct option. Next one. Yes, the question number 5 here. Just read it carefully. PQR is a right angle triangle prism with other angles as 60 degree and 30 degree respectively. The refractive index of the prism is given to be 1.5. The PQ has a thin layer of liquid. Okay, PQ के ऊपर एक liquid का layer यहाँ पे दिख रहा है. This is the layer of liquid here. Okay, light falls normally on the face PR. Okay, तो इस PR face पे light जो है वो बिल्कुल normally fall हो रहा है. Yes. For the total internal reflection, what is the maximum refractive index of the liquid here? तो liquid का refractive index कितना होना चाहिए अगर हम चाहते हैं कि total internal reflection यहाँ पे हो जाए. ठीक है, तो अभी देखो total internal reflection के लिए ये जो angle theta है यहाँ पे, it should be the critical angle, right? And if theta is critical angle, then sin theta must be actually equal to 1 upon mu, and that mu is also the relative refractive index, which is the refractive index of glass, that is denser medium, with respect to the refractive index of liquid, that is rarer medium. Okay, तो यहाँ पे ये sin theta is equal to 1 upon L mu g, ये फॉर्मूला हमको मिलेगा. This is the condition which we have to use and find out the value of mu here. Okay, तो refractive index हमको ढूंढ के निकालना है. ठीक है, but as actually we know that the relative refractive index of glass with respect to liquid is actually going to be the ratio of the refractive index of glass to the refractive index of liquid here. But as it is the refractive index of glass is already given to be 1.5, we can just put it here, and just we can modify this formula here. ये formula पहले हम यहाँ पे modify करके लेंगे ताकि हमको ये मिल जाएगा sin theta is going to be equal to, so यहाँ पे 1 upon, here it will be mu g upon mu l, so that we can just write this as equivalent to sin theta to be simply equal to mu l upon mu g. Correct है? But as we can just see in the diagram that this theta is actually going to be 60, just because this angle is 60 here, this angle is going to be 90 here. So from right angle triangle we can expect this angle to be 30 here. Okay, and if this angle is 30, then this which is complementary to it must be exactly 60 actually, right? So theta must be equal to 60 here. So from the 10th standard geometry we can just know that this theta is going to be 60 degree. Okay, and if we just put it here in this formula, then we can just get this sin 60 is equal to mu L, which is the refractive index of liquid, which is that is to be found out, upon mu G, which is actually the refractive index of glass, that is 1.5. So if we just try to find this out, so sin 60 is actually root 3 by 2. Already we know that, and here it is mu L upon 1.5. So if we just simplify this further, This 1.5 can be transferred that side so as to get it as root 3 upon 2 into 1.5, which can also be written as 3 by 2, no doubt. That is actually going to be mu L here. So mu L actually happens to be 3 root 3 upon 4, okay, where root 3 we know actually it is equal to 1.732, and that is to be divided by 4 here, so that we can just get this as 3 2s are 6, 3 3s are 9, and 3 7s are 21, 2 carry, and 3 plus 2 5. 5.196 divided by 4, which actually comes out to be 1.299. Matlab approximately it is going to be 1.3 actually, right? So 1.3 can be selected as a best option, which is already available in option B here, okay, which must be the correct. Let us see the next one. That is sixth question here. Yes, just read the question carefully. When the ray of light, when a ray is refracted from one medium to another medium, the wavelength changes from 6000 to 4000. Okay, so lambda 1 is given to be 6000, and lambda 2 is actually given to be 4000 here. Okay, angstrom obviously. So the critical angle of for the interface will be, okay, देखो रिफ्रैक्टिव इंडेक्स का और एक फॉर्मूला हमारे पास है. रिफ्रैक्टिव इंडेक्स 1 mu 2 is actually equal to wavelength of light in the first medium upon the wavelength of light in the second medium. So if we just try to use it here, then the refractive index of medium 2 with respect to 1 can actually be found out to be simply equal to lambda 1, which is 6000 here, that is divided by 4000 here in this way, which actually happens to be 3 by 2, or we can call it as 1.5. Okay, so 1.5. Yes, but already critical angle we have to find out. So critical angle के लिए हमारे पास formula है sin IC is actually going to be equal to 1 upon the refractive index of denser medium with respect to rarer medium. So here it is going to be refractive index of medium 2 with respect to 1, which actually happens to be sin IC is going to be 1 upon 1 mu 2, which is actually 3 by 2, right? So if we just put this 3 by 2 here, then its reciprocal actually becomes 2 by 3, and hence we can be able to get this sin IC equal to 2 by 3. So we can just get this IC to be equal to sine inverse of 2 by 3 as a final answer, which is already there in this option C here. Okay, so in this way we can try to find out the critical angle. Yes, go to the next one. Yes, the seventh one. Just read the question carefully. A ray of light makes an angle of 10 degree with the horizontal above it and strikes a plane mirror which is inclined at an angle theta to the horizontal. The angle theta for which the reflected ray becomes vertical is, okay, so you'll have to draw the diagram. See here, suppose there is a plane mirror which is inclined at an angle theta with the horizontal. Okay, so that means suppose this is the plane mirror which is inclined at an angle theta with the horizontal, like this. Okay, this is horizontal, and this plane mirror is making an angle of 10 degree with horizontal. Okay, yes, the ray of light makes an angle of 10 degree. Sorry, it is not 10 degree here, it is theta here. Okay, तो inclination angle जो है plane mirror का वो theta है, ठीक है. a ray of light makes an angle 10 degree with horizontal above it. Okay, that means ray of light जो है, it is making an angle of 10 degree with the horizontal above it. So how should we draw the ray of light then? Suppose this is the horizontal. We can just extend this horizontal here, and the ray of light is making an angle of 10 degree with the horizontal and above it. Okay, so suppose this is the ray of light where this angle is actually going to be 10 degree here. Okay, ये angle जो है वो 10 degree दिया हुआ है. ठीक है, this is the ray of light actually which is incident on this plane mirror. ये surface है mirror का जो उसके ऊपर strike करता है, and then it will just follow the laws of reflection. So laws of reflection draw करने के लिए हमको यहाँ पे एक normal भी draw करना पड़ेगा. So this is going to be the normal here. Okay, so this is the normal, and the ray of light will actually be get reflected from this point and just travel in this direction here. Okay, so अभी हमको क्या चाहिए कि value of angle theta for which the reflected ray becomes vertical. Okay, तो मतलब हमको ये reflected ray जो है, ये वाला ray जो है वो vertical बनाना है. ठीक है, that means we want to find out the angle theta. देखो ये एंगल थीटा जैसे हम बढ़ाते जाएंगे तो वैसे वैसे रिफ्लेक्टेड रे जो है वो भी ऊपर ऊपर जाता रहेगा. तो वी वांट दैट दिस रिफ्लेक्टेड रे बिकम्स वर्टिकल. सो व्हेन इट इज पॉसिबल, अभी एक बात सिंपल सी बात देखो यहाँ पे कि ऐसा है कि ये देखो ये जो प्लेन मिरर है इट इज मेकिंग एन एंगल ऑफ थीटा डिग्री विथ हॉरिजॉन्टल, राइट. सो इसका जो परपेंडिकुलर है ये नॉर्मल, तो वो नॉर्मल भी वर्टिकल के साथ उतना ही एंगल करेगा, बराबर है. इसलिए ये बात सामने रख के हम थोड़ा डायग्राम जो है वो डायग्राम से तुमको वो क्लियर नहीं दिख पाएगा, बट चलो थोड़ा डायग्राम हम चेंज करते हैं स्लाइटली. ओके, सो सी सपोज दैट दिस एंगल ऑफ एंगल मेड बाय दिस रे ऑफ लाइट प्लेन मिरर इज सपोज इंक्रीज्ड स्लाइटली लाइक दिस. ओके, तो ये एंगल अगर हम थोड़ा इंक्रीज करेंगे इस तरह से, ठीक है, तो कभी ना कभी ऐसा होगा ना कि ये जो रे ऑफ लाइट है तो वो रे ऑफ लाइट इसके ऊपर इंसिडेंट होने के बाद, रिफ्लेक्ट होने के बाद वो वर्टिकल बन जाए. तो ये हमको एक्सपेक्टेड है. तो दिस एंगल शुड बी सच दैट दिस लाइन, दिस रे ऑफ लाइट विल जस्ट बिकम वर्टिकल. ये जो रे ऑफ लाइट है ये एक्चुअली वर्टिकल बनना चाहिए. ठीक है, ये वर्टिकल बन गया सपोज ऐसे. ठीक है, तो अगर ये वर्टिकल बन जाता है, यस, देखो ये अगर वर्टिकल बन गया तो उस केस में ओके, तो अब देखो इस प्लेन का इस हॉरिजॉन्टल के साथ बना हुआ एंगल जो थीटा है यहाँ पे, तो वो एक्चुअली इस प्लेन के परपेंडिकुलर का, तो ये परपेंडिकुलर भी एक्चुअली बेंड होगा ज़रूर. ये जो नॉर्मल है उस प्लेन का वो भी ज़रूर टर्न होगा और ये ऐसे बनेगा एक्चुअली. सो वी कैन जस्ट सी दिस इज़ अ नॉर्मल हियर. सो इस नॉर्मल का और इस वर्टिकल के साथ बना हुआ एंगल सेम ही होगा. तो अगर ये एंगल थीटा है तो ज़रूर यहाँ पे ये वाला एंगल जो है वो भी ज़रूर थीटा होगा, बिल्कुल. और अगर ये थीटा है तो ज़रूर ये भी थीटा होगा. और अभी इसमें हमको थीटा निकालना है, तो अभी अगर ये थीटा, ये 2 थीटा हो गया और ये एंगल जो है तो वो हमको पता नहीं कितना है, बट वी कैन जस्ट यूज द exterior angle theorem here. Okay, so this angle actually is 90 total, so that we can just call this angle to be 90 minus theta here. Okay, and if this is 90 minus theta, then we can just apply the extra angle theorem. This extra angle here is going to be the sum of these two remote interior angles, right? So if we use it here, then we can be able to get that this theta must actually be the sum of this 10 and 90 minus theta, so that we can just get this 2 theta here to be simply equal to 100, which gives theta is equal to 50 degree as a final answer, which is already going to be there in this option B here. Okay, so that's all for today. We can just do the remaining sums in the next lecture. Okay, thank you all of you.